Welcome back, everyone. In this video we are going to learn how to use the Mod Path utility to do particle tracking analysis. This is a really nice post-processing tool that allows you to look at groundwater flow directions and travel times. And ModPath is a utility developed by the USGS, United States Geological Survey, as a companion package to Modflow. It's been around, oh gosh, since the very early days of Modflow, and very easy to use. So to do this, or to introduce how ModPath works, we're going to go through the GMS Mod Path tutorial, which is shown here. And this involves, if you go to the Aquaveo website and click on the Modflow related tabs in the tutorial section, there's this zip archive here in this PDF file, which I've already downloaded, that we'll be using. So I'm going to jump over to GMS, and we're going to do File Open, and jump down into the ModPath folder. And there's a Start subfolder, and what we're going to do is we're going to read in one of the solutions to the East Texas model that we did in one of our earlier videos to learn how to use the conceptual model approach in GMS. And we're going to use this for our particle tracking analysis. And as you may or may not recall, in this particular exercise we had this alluvial aquifer that we built a model for, and then there's a little square polygon right over here. Let me see if I can highlight that, and let me expand all the data here in the Project Explorer window. There's this little polygon right here, and that represents the hypothetical location of a landfill. There's not really a landfill there, but assuming someone was proposing to put a landfill there, we could use this model to determine where the leachate would go if it leaked from the landfill. And as you may recall, there is a well here and a well here, and we have rivers on the bottom and on the right of this model. So the question is, what is the capture zone for this well over here? Does it include the landfill polygon? And if we're going to do backward tracking from the wells to get the capture zone for this well, and then we're going to do forward tracking from the landfill polygon, and use those two different sets of results to determine what impact this landfill would potentially have on the river and on the well. So to start with, you'll notice we have a Mod Path menu up here. Sometimes when you open up a file, that menu might not be visible. You can always go to the Edit menu and look in Model Interfaces and make sure that's turned on. If you're ever looking for a menu for a model interface, you don't see it, this is where you should always look for that. Now, to use Modflow, again, it does particle tracking analysis, and travel time is very important. And whenever you're dealing with travel time in a Modflow model, the issue of seepage velocity versus Darcy velocity comes up. If you calculate travel time using Darcy's law directly, you get what's called Darcy velocity, which isn't really the true velocity at which things travel in the groundwater. And so you divide Darcy's law, or the Darcy velocity, excuse me, by the porosity, or effective porosity in the soil. So in order to get accurate travel times, we have to enter a porosity for the Modflow, each of the Modflow cells. And if you go to the Mod Path menu and select porosity, you'll see there's a grid of porosity values, one per cell, and that is on all layers. And in GMS, this is defaulted to a value of 0.3, which is a reasonable default to use. And so we're just going to leave that as 0.3. You can also select a set of cells. Let me go to the grid module and then right click and do cell properties, and down here there should be there's a porosity value right here that you can edit. So you can edit it on an individual cell by cell basis. You can define polygons in the map module and map them over. You can interpolate them using the 2D scatter point module. Pretty much the same way you set up things like hydraulic conductivity, recharge, etc. You can use to define your porosity. So so we're all set there. And so the next thing we're going to do, we're going to start generating path lines. And to do that, you generate what are called particles, or particle starting locations. These are hypothetical little particles that ModPath will then track either forward or backward in time, depending on the context, to generate your path lines. And so we're going to go into the ModPath menu, and there's a menu command that says generate particles at wells. And what this does is it finds each of the wells in your input, and you can designate whether you want this around injection or extraction wells. Extraction meaning you're pumping water out, injection meaning you're putting water in. Most wells are extraction wells. And it distinguishes between the two, because with one you want to do forward tracking, or with extraction wells you want to do backward tracking. With injection wells you want to do forward tracking. So we're going to do extraction wells, which is what both of these are. And you tell it how many particles you want, and then it builds a little circular ring around each around each well, and generates a ring of particles that it then tracks. And so I'm going to click OK, and just like that, you will see a set of path lines for these two wells. This one goes kind of to the left, and this one goes up and to the right, the northeast direction. And we're mainly interested in the capture zone for this well over here. And so we're going to use this tool right here. It's the Select Particles tool, Particle Starting Location tool. And I'm going to select those particles. I'm going to hit the delete key and get rid of those. So we're just looking over here now. Now I'm going to use the magnify tool to zoom in, and now we can see that we have a capture zone for this well. Pretty much. So let me zoom in a little closer, and you can kind of see how these how these particle starting locations are set up, and how they go out as you go away from the well. Now these particles are tracked backwards in time, and so they go up until they, in this case, until they exit through the river. So basically they go back until they hit the river. Now we're going to do something else here. We are going to go into side view, and so this is looking down in side view. We can switch which slice we're looking at, but as you may recall, we have this well screen spans multiple layers, and so it ends up generating a well representing some portion of the flow for that well. It generates a well object in each of these two layers, and so we end up with two rings of particles in each of those layers. Now, by the way, there is a way to more explicitly delineate how those particles are distributed along the well screen. You can have greater control over that, and we'll talk about that a little later. But anyway, that's what we're looking at when we're looking in plan view. This is kind of a 3D view. This also shows these path lines are three-dimensional. I mean, they have an X, Y, and a Z component, so it's not just 2D. So that works out really well. Now let's go back to plan view for a second, and again, so these particles are tracking all the way until they hit some boundary, and in some cases it's useful to determine or delineate what the travel times are. And by the way, if you select these particles using the Select Particles tool, if you look down at the bottom of the window, it tells you a bunch of things. It tells you you have 40 particles selected, and the lengths, the min length is 718, the max length is 1,272, so this would be the length in meters in this case. The average is 995. The travel times, the minimum is 11,000 days, the max is 22,000 days. And then if I expand the window, you'd be able to see the average travel time as well. You can also click on individual lines, and it will tell you the length and the travel time just for that particular line. Now let's go up to the Mod Path menu and select Display Options. You can also turn on direction arrows, and with a time interval, I'm going to put in 2,000 days. And what this does is, let me turn off some things to make this a little easier to see. Let's turn off that map module data. There we go. And now I'm going to zoom in a little bit. So what that does is each of these rows of arrowheads represent 2,000 days. And so you can kind of begin to feel, 2,000, 4,000, 6,000, and so forth. You can get a feel of the time scale here. These are very slow travel times. Groundwater, in a lot of cases, some cases it moves fairly rapidly, in some cases it doesn't. But that's what's going on here. It's moving pretty slowly. Now, by the way, over here on the left, you'll see that when we created those particle sets, a new folder in the Project Explorer window was created called Particle Sets, and inside that it has a particle set symbol. So a particle set is a set of particles or path lines, and you can have more than one of those in memory at any particular time, but each particle set has a set of properties. So I'm going to double click on this, and it says, okay, you've got 40 points, you're tracking backward in time, and how it terminates is it tracks to the beginning, but we can also tell it we want to track for a specified duration. So we can, for example, we might say, well, we want to know how far these particles go in 3,000 days. What is the 3,000 day capture zone? And so if we click OK, now what we're looking at is the capture zone for a 3,000 day travel time. And by the way, let me go back to the display options. We can turn off those direction arrows if we want, and we can also, in addition to the path lines, you notice there's a purple boundary around this. It's calculating a set of capture zone, or a capture zone for these path lines by generating it's like drawing a polygon around those capture zones. And we can do a polyfill on that as well. So now you can see it's got that yellow background. It makes it pop a little more. And so that is the capture zone for 3,000 day travel time for these wells, or for this particular well. Now, suppose we wanted to display both a 3,000 day and the 1,500 day capture zones for some reason. Let me zoom in here again. We can do that by duplicating these particles and creating a second particle set that has a travel time of only 1,500 days. And so I'm going to right click on this particle set and select duplicate, and then I'm going to double click on the result, and I'm going to call it I'm going to call the first one 1,500 days, and the next one I'm going to call 3,000 days. You can name these particle sets whatever you want. And I'm going to change the travel time on this last one to 1,500 days. And I'm also going to, well, let's see, I'll click OK. And now, basically what's happening is what I've got over here changes the drawing order. So if I the one whatever's at the top is drawn first. So if I change that drawing order, and by the way, let me go in here and turn off the path lines for just a second, so we just see the capture zones. So now this background bigger polygon is the 3,000 day capture zone, and the smaller one is a 1,500 day capture zone. And again, I can drag these around to change the order, but you want this 1,500 one to be drawn last, so we move it to the bottom of the display order in drawing. And so, yeah, there we have it. A couple of different capture zones. The more you'll notice the boundaries here are a little irregular. The more path lines you use, the more smooth that will become. And so that's backward tracking from the wells. Now let's turn our attention to forward tracking from the landfill. You zoom in again right here, and let's turn on the recharge polygon. Turn off the grid for a second. And so what we want to do now is do forward tracking from this particular location. And so before we do that, we need to create a new particle set. If you have a particle set in memory and you go to create new particles, it will just be added to the currently active particle set. Now, the first time we did this, there was no particle set, so we created one. But we have one now, so we need to create a new one. So I'm just going to right-click here, select New Particle Set. I'm going to go in here and I'm going to call it Landfill, and it's going to go forward in time. And now I need to select a set of cells under that landfill. I can do this one of two ways. I can simply use that rectangle as a guide and select those cells, and that's the easiest way to do it. There's also a way in the you can select a polygon in the map module and right click and say select intersecting objects, 3D grid cells, and that will select them as well. But once they are selected, we go to the Mod Path generate particles at selected cells command, and this allows us to create a set of particles at on the water table surface. Now, if you want to, you can turn on these extra options, and you can distribute the particles any way you want. But the easiest thing, if you do the simple approach, you just drag this bar. That tells you for each individual cell how many particles that you want generated. And you can do 1 particle per cell if you want, or we can do 4, 16, 9. We're going to do 4 particles per cell in this case, and click OK, and nothing happens. What's going on? Let's see, do we have that go in the right direction? Forward to end. Okay, I know what's going on. I got a little confused there, but the reason we don't see anything is we turned the display of path lines off. So let's turn those path lines back on, and there we have it. So yeah, I turned the path lines off to display these capture zones over here, and I forgot to turn them back on. That's why we couldn't see them. So now you'll see that these path lines are going forward in time, and that creates a pretty dense set of path lines. And if I decide, yeah, maybe that's a little too dense, you can always go back and hit the delete key and delete those, and then we can do that again. And in this case, we do generate particles at selected cells. I'm just going to go with 1 particle per cell in this case, and that should give us plenty. Okay. All right, now you'll notice that all of those path lines go down to the river at the bottom. Now, what happens if we were to increase the pumping rate at this well? So let's try that. Let's go over to the source sink coverage. I'm going to turn off the 3D grid data for a second, and I am going to double click on that well, and I'm going to double the pumping rate. It's pretty small, 300 cubic meters per day. I'm going to make that 600. This is a small model. And then I'm going to say map to Modflow, and then let's do file, save as. We'll call this modpath1.gpr, something like that. And we'll run the solution and turn the grid back on. And now you'll see a couple things have happened. These capture zones are bigger now for the well because we have a larger pumping rate, so the capture zone is going to cover a larger area. Let me turn those off for a second. But you will also see some of these path lines go to this well, and then some go down to the bottom of the river. Now I'm going to change the contour options here so this is a little easier for us to see. Let's see, display options, 3D grid data, contours. Let's do color fill plus linear. Actually, let's just do linear. There we go. All right, that's a little better. And you turn off that polygon in the background, so now you can see that a little better. Now, what I want you to see is we have some of the path lines go to the well and some to the river. There's a way you can color these path lines based on where they start or where they end. And so we're going to go into the Mod Path display options again, and we are going to by path lines it says color, and we want to change them so the color is defined by its ending code. And I'm going to click OK. Now before I get too far with that, I'm also going to zoom in right here, and I am going to go to the 3D grid module, and I'm going to select this cell right here and double click on it, and down at the bottom there is a ModPath zone code. I'm going to change that to 2 and click OK. So now this cell is a ModPath zone code of 2 and everything else is a zone code of 1. And now if I go back to the display options and I say I want it colored by ending code, now it shows me I have 2 codes, and I can have it automatically assign colors or I can assign my own colors. And in any case now, let's see, why is that not refreshed? ModPath. Let's run ModPath again. Alright, now I'm stumped again. Particles, path lines by, ending code. I want it by, yeah, no, that is right. That is the end code. The ones that end at this, oh, you know what? I know what the problem is. So remember, we have 2 wells here, one in each layer, and I selected the cell in the top layer, and it turns out if we go into side view, you'll see that these path lines are going to the well in the lower layer, I believe. So let's try that. Let's test my theory here. I'm going to go now, I'm going to switch to layer 2, and I'm going to zoom in, and I am going to select that cell right there, change it to 2, and yeah, that did it. So sure enough, they were terminating in the well in the second layer. So now you can see that all of the particles going to this well are green, the rest of them are blue. Now it's pretty easy to distinguish the two, but when you have a much denser set of path lines, or maybe like a lot of wells where they're terminating, this can really be a useful display technique. And now finally, once again, we can generate capture zones for this. So let me turn on the capture zone. It says delineate by well. We could delineate by zone code. See what happens. Oh, there we go. And you'll notice that it again draws a polygon around all of these path lines, but there are these two sections where it's kind of concave, and it spans that entire section. There's an option here called the thin triangle ratio, and if you change it from 0.98 down to 0.9, you can notice that it pulls that back. Now that if you look up the GMS reference manual, it'll tell you the logic that is used on that thin triangle ratio thing. It's an algorithm it uses to determine capture zones, and generally that number should be between 0.9 and 0.98. The default is 0.98. But if you have big concave regions like that, you might want to make it a little smaller. Of course, you can always draw your own capture zones by hand using polygons in the map module, but this is an automated way to do it. So anyway, so we've done backward tracking, forward tracking, played around with the display options. There's no limit to the number of things you can do with Pathlines Mod Path. It's a very simple, easy to use utility and gives you some really nice insights into what your model is doing. And again, like we did before, we could go in here and say, well, instead of tracking all the way to the end, what happens after, 20 years or so? Let's see, 10 years would be 3650, so about roughly 7,000 days would be 20 years. That's how far the leachate would travel in about 20 years. So you can do all sorts of analysis, several kinds of analyses like that. All right, so that concludes our introduction to ModPath. Thank you for your time.